In the vastness of the universe, some mysteries hide in plain sight. One of them, silent, cold, and puzzling, lurks in the ancient light left over from the Big Bang. It's called the cold spot, and it's unlike anything else in the observable cosmos. But what is it really? A fluke of nature? A shadow of something unimaginable? Or a fingerprint from another universe? Before we dive deep into this strange anomaly, make sure to like this video if you're fascinated by space mysteries, and subscribe if you're curious about the hidden truths of the universe. Your support helps the channel grow and brings more cosmic enigmas your way. To understand the cold spot, we have to look back almost 14 billion years, right to the beginning of time. When the universe was born in the Big Bang, it was unimaginably hot and dense. As it expanded and cooled, light from that early fireball began to travel freely through space. That light, stretched thin over time, became what we now call the cosmic microwave background, or CMB. It's the oldest light we can observe, a snapshot of the infant universe, frozen in time. In 2004, NASA's WMAP satellite mapped this ancient light with extraordinary precision. What it found stunned scientists: a region in the southern hemisphere of the sky that was significantly colder than expected. This cold spot wasn't just a little dip. It was a sizable region, nearly 1.8 billion light-years across, with temperatures slightly lower than its surroundings by about 70 microkelvin. That may sound tiny, but in the realm of cosmic measurements, it's huge. Later, the European Space Agency's Planck Satellite confirmed WMAP's findings, ruling out instrumental error. The cold spot was real, and it wasn't going away. This prompted a question that still haunts cosmologists. Why is this patch of the universe so cold? One early explanation was statistical chance. The universe is a noisy place. Some fluctuations in temperature are to be expected. Maybe this was just an extreme case of that randomness. But as the data got better, this explanation started to lose ground. The odds of such a cold region appearing by chance were incredibly low, around 1 in 100 or even less. Another idea was a supervoid, a massive, nearly empty region of space that lies between us and the cold spot. In theory, as light travels through such a void, it loses energy, leading to a slightly cooler signature in the CMB. This is known as the integrated Sachs-Wolf effect. For a while this seemed promising. A team did find evidence of a large void in that direction, but soon follow-up studies cast doubt. The void just wasn't big or empty enough to account for the anomaly. The theory began to unravel. With conventional answers falling short, more exotic ideas entered the stage. One of them involves something called cosmic textures, topological defects in space-time that might have formed during phase transitions in the early universe. You can think of them like scars left on the fabric of reality when the universe cooled and fundamental forces separated. These textures could, in theory, leave behind cold or hot spots in the CMB. But again, there's a catch. We haven't seen evidence of other textures, and this one might still be a stretch. Then there's the most mind-bending possibility of all: the cold spot as evidence of a bubble collision, an event predicted by some versions of inflationary cosmology. In this scenario, our universe is just one bubble in a vast multiverse. If another bubble universe collided with ours in the early moments of existence, it could have left a lasting imprint in the CMB, a cosmic bruise. The cold spot might be that bruise, a scar where two realities once touched. Of course, the multiverse is still a speculative idea. It's beautiful, it's elegant, but it's also untestable with our current tools. For now, it remains on the edge of science, somewhere between theory and philosophy. So where does that leave us? After nearly 2 decades of study, the cold spot remains unexplained. Every plausible theory has holes. Every simple answer falls short. It's like a glitch in the cosmic code, one we don't yet understand. Some scientists still hold that it's just a statistical outlier. Others believe it hints at physics beyond our current grasp. A few even suspect it's the best observational clue we have to the existence of a multiverse. In a way, the cold spot is a reminder of just how much we don't know. It challenges our models, our assumptions, even our understanding of reality itself. In a universe that's 93 billion light-years across, filled with trillions of galaxies, it's a single quiet anomaly. But sometimes it's the quietest places that hold the loudest secrets. So is the cold spot just a cold patch of sky or a crack in the cosmic mirror? The truth for now is out there, silent, waiting, cold.